What is the integral from pi over 6 to pi over 4 of cosecant z cotangent z dz? Well, when you're looking at things like this, you want to remember, you probably want to have these in your notes, the formulas for the derivatives of all the trig functions. So derivative of sine is cosine, derivative of cosine is negative sine. Remember, derivative of all cofunctions is negative. See down here, cotangent negative, cosecant negative. Derivative of tangent, secant squared, derivative of secant, secant tangent. And then the cotan comes from the just coing the tangent. If tangent is secant squared, then cotangent is cosecant squared with a negative because derivative of all negative cofunctions are negative. And then cosecant just comes from coing the secant. You see that? Secant is secant tangent, then cosecant is cosecant cotangent and negative because derivative of all cofunctions is negative. All right, with that in mind, what I want to do is I want to do the antiderivative of cosecant cotangent. So you see cosecant cotangent right here. So antiderivative, I want to go back this way. But is it positive or negative cosecant? Well, you see how the sign has to change? So it's going to be negative cosecant. If you're not sure about that, try putting positive here. Let's do it right. Yeah, I'll do it right here. Positive cosecant at first. It's not right. Here's how you could check. Because if you took the derivative, would it go back? No. Because the derivative of cosecant would go to negative cosecant. There's no negative there. So therefore, we got to go, oh, so it's got to be like negative cosecant cotangent because the derivative of negative cosecant cotangent, cosecant would put another negative in front, another negative, two negatives, positive cosecant cotangent. So that's correct. Okay, but now this one's a definite here. We've been doing a lot of indefinite in this section, but this one we got to go back and we got to put on bounds. This one has definite, here, let me do that a little better. This one has definite bounds, and we've got to follow those bounds. And they go from pi over 6 to pi over 4. Okay, so remember how this works. You take the top bound and you plug it in. So I'm going to get minus cosecant, minus cosecant pi over 4. Subtract, right? And then minus cosecant pi over 6. Plug in the second one. So is that making sense? So you plug in the top bound, subtract, plug in the bottom bound. Then these double negatives in the middle, these are going to become positive, huh? So it's going to be negative cosecant pi over 4, double negative positive cosecant pi over 6. So let's just go do those on now. Oh yeah, Desmos doesn't have cosecant. So what are you going to have to do? You're going to have to do, remember, cosecant is the flip of sine. So that's going to be negative 1 over sine. Oops, I didn't do that so well. Pi over 4 plus 1 over sine pi over 6. Do you remember that? Cosecant is the flip, is the upside down of sine. So or you could type in cosecant probably. Let me see. Let me see if I can do that. Oh, Desmos, I don't remember, honestly. What was it supposed to be? It's supposed to be, I'll try the minus cosecant pi over 4. Minus, oh no, there's no way to do it. 1 over sine pi over 4, pi over 4. Okay, there we go. Minus, I'm doing this right here. I'm doing minus 1 over sine pi over plus 1 over sine pi over 6. Plus 1 over sine pi over 6. Boom, there we go. We got that number, 0.5857. 0.5857. We can give that answer. 5857. They're giving this exact, it's the same thing. Let me show you. I'll show you it's the same. It'll take it either way. 2 minus root 2. If you did 2 minus root 2, whoops, I didn't do the 2. 2 minus root 2. See how those are exactly the same number? So we get the right thing. It's the same thing. You can just type in that decimal. And so there we go.